Hello calculus and welcome back. In this video I'm going to talk to you about the derivatives of logarithmic functions. So first we're going to talk about the derivative of the natural logarithm. Of the function ln of x. That's a logarithm that uses e as the base. So if I have x strictly greater than 0 and my function f of x is equal to the natural log of x, then the derivative of that function is equal to 1 over x. And if I have a generic function, let's say if I have, again, x strictly greater than 0, and my function g of x is equal to log base b of x, then the derivative of that function is equal to one over x times the natural log of b. So let's do some examples of using this. So let's take this derivative. Let's suppose I have a function f of x equals the natural log of this happy polynomial x cubed plus 3x minus 4. So this is a chain rule problem. Our outside function is the natural log, and our inside function is this happy little polynomial. So our derivative, f prime of x, we're going to take the derivative of the outside function, which should be 1 over x cubed plus 3x minus 4, times the derivative of the inside function, which is 3x squared plus 3. So then that gives us our derivative f prime of x is equal to 3x squared plus 3 over x cubed plus 3x minus 4. I want to show you how you can use properties of logarithms to make a derivative easier. So let's do this using properties of logarithms. Let's suppose I give you this function. F of x is the natural log of x squared sine of x over 2x plus 1. And I want you to take the derivative of this beast. Well, right now it would be a little bit scary because I have a lot of chain rule, I have the quotient rule, I have the product rule, I have all of those things in here. But if you remember your algebraic property of logarithms, the quotient of two logarithms can be written as the difference of two logarithms. And the product of two logarithms can be written as the sum. I almost forgot my log, plus ln of sine x minus ln of 2x plus 1. And I can use my exponent law to bring this down here. And so now I have f of x is equal to 2 ln x plus ln of sine x minus ln of 2x plus 1. Now I still have to use the chain rule here, but I'm done with the quotient rule, I'm done with the product rule. I have some nicer derivatives to take. So we're going to take the derivative of this function, and I'm going to go piece by piece. So we'll do the blue piece, and then we'll do the green piece, and then we'll do the yellow piece. So the derivative of what you see in blue is going to be 2 times the derivative of ln x, which is 1 over x, 2 times 1 over x, And that's what we have in blue. And then we're going to add to that the derivative of what we have in green. And this is where we're going to use the chain rule. So we'll end up with 1 over sine x. That's from taking the derivative of the natural log. And then we'll multiply that by the derivative of sine of x, which is cosine of x. And that's going to be the derivative of what we have in green. And lastly, we'll subtract this, which will give us another chain rule. So we have 1 over 2x plus 1, and that's the derivative of the natural log piece. And then times the derivative of this function inside, which will be times 2. And now we just have some simplifying to do. So we have f prime of x is equal to 2 over x plus cosine x over sine x minus 2 over 2x plus 1. Now, some of you see this right away and some of you are like, hey? This is equal to the cotangent. This is one of those trig identities that you were supposed to memorize way back when. If you didn't, that's okay, but you might want to spend some time on it now. So we have 2 over x plus the cotangent of x minus 2 divided by 2x plus 1. And that derivative was a lot easier to take than if we had tried to do it the long way. All right, let's do a couple of other ones here. You know what? Actually, I'm going to stop here and let you guys read the rest of the section. And